Hello, everybody. My name is Justin, and I chose the workout problem, which is follows. Downtown blocks in Salt Lake City are 660 by 660 feet. A person walks on a street 2 blocks south, 3 blocks west, and 6 blocks north. What is the magnitude of displacement of the person in feet? Use north and the east directions to be positive. Well, the givens in this problem are in the statement. It states that north and east directions are positive and south and west directions are negative. And then also the exact size of the city blocks are given in the units feet, and they are 660 by 660 feet. And so what we're trying to determine is what the magnitude of displacement of the person is in feet. Well, before we get into the actual workout problem itself, step by step, I'm going to go ahead and show you an illustration of a graph that I constructed. And here we have a starting point in the middle of this because of the direction. I don't want to run out of space. But each one of these squares equals 660 feet by 660 feet. So each one of these squares represents a city block. Okay. So as the statement said, the person starts out and walks 2 blocks south, which is -2 times -660 feet. And then that person goes 3 blocks to the west, which would also be -3 times 660 feet. So a negative vector. And then also, finally, that person goes 6 blocks north, which is a positive vector, at 6 times 660 feet. Over here, I also made a legend with the values of the cardinal directions. North positive, east positive, south negative, west negative. All right. So going back to the problem here. Once again, what is the magnitude of displacement of the person in feet? So I went ahead and recorded the actual distances here. So the 2 blocks south, which would be a negative quality, times 660, 2 times -2 times 660 equals -1,320 feet. Then the person went 3 blocks west, which calculated to -1,980 feet. And then 6 blocks north calculated to 3,960 feet, which is a positive vector. So kind of the simple equation for this was the displacement equals the sum of the vector distances. So we plug in the numbers that we have up here, -1,320 feet plus -1,980 feet plus 3,960 feet, and we get a grand total of 660 feet. So that equals out to be the displacement of the person. And then the magnitude is 660 feet, and then the sign here is positive, and the unit that is used is feet. So that is the actual distance that we got. Another way to look at this is, if to make it maybe a little bit easier to understand, if the person was just to travel north or south, you could just take this distance, and if you started here and you went 1, 2, and then these 3 blocks, 3, 4, 5, and then you went 6 blocks up. Here's number 5, and then number 6. From the start to the finish, your total displacement would have been 660 feet. So that's just kind of another way to kind of double check that, kind of a visual way to do that. So, but once again, my name is Justin Jones, and that concludes my presentation. Thank you.